The third learning objective in section 4.1 is to interpret statistical graphics for quantitative variables, including discussing center, shape, variability, and unusual observations. This first example asks which histogram depicts a larger standard deviation. Standard deviation is one of our measures of variability. So let's look to see which histogram shows data values that are more spread out, less consistent with each other. Both histograms show a shape that is pretty bell-shaped. We've got a peak in the center, and then we sort of taper down towards the extremes. So there isn't one histogram that has way more values that are at the extremes than the other one. The standard deviation, since it measures the typical distance from the mean, would be larger if you had a lot more data values at the edges and a lot fewer data values in the center. But these both have most data values in the center and few data values at the edges. So let's look to see how far apart from each other the edges are. Looking at graph A, we can see the first bar starts at 40 and the last bar ends at 60. That's a range of 60 minus 40, which is 20. Looking at graph B, the first bar starts at 30 and the last bar ends at 75, which is a range of 75 minus 30, which equals 45. The range of graph B is over twice as big as the range of graph A. So we can see that there is a lot more variability in graph B, which means it will also have a larger standard deviation. This next example gives us a histogram that shows the heights of 300 randomly selected women. Choose the box plot below that represents the same distribution of the heights of the 300 randomly selected women. I'm going to move this up so you can see all of the box plots. And now let's compare them. The first thing we can notice is that the shape of the histogram of heights is fairly bell-shaped, pretty symmetric. There are two graphs below that are not symmetric. Graph B is left skewed. You can see that the left side of the box is longer or wider than the right side of the box, and that line coming out of the box on the left side, sometimes called a whisker, is much longer than the line on the right side. This makes graph B left skewed. Graph D has a wider right side of the box than a left side, and a longer right whisker than a left whisker, which makes graph D right skewed. So we can eliminate those two as answers because they have a different shape than the histogram. How will we tell the difference between A and C? Both are pretty symmetric, not perfectly symmetric, but our histogram is also not perfectly symmetric. We can look at the horizontal axis. You can see that the histogram starts a little bit more than 55 and ends a little more than 70. Let's look at the horizontal axes of the heights in graphs A and C. Graph A goes down below 60 and goes up above 70. That matches what's in the histogram. But graph C, while it does go below 60, it only extends up to about 67. There are definitely data values above 70 in this histogram, and so therefore it can't be graph C, and the correct answer is going to be graph A. The third example says Brickyard Bakery is trying to predict how many loaves to bake. In the last 100 days, they have sold between 90 and 140 loaves per day. The dot plot of the number of loaves they sold for the last 100 days is given, along with the summary statistics for the bread sales. Use these statistics to create a box plot. You can approximate the outliers just using the dot plot. So looking at the dot plot, we can see that there are some extreme values that are over here to the right. Looks like they are at about 135, 138, and 140. So those are going to be the outliers. We're going to mark those with these X's in our box plot. They could be asterisks or dots. Then to create a box plot, we use the values of the minimum, Q1, the median, Q3, and the maximum. So the left whisker starts at the minimum, which is 90. The box starts at Q1, which is 98. The line in the center of the box is at the median, which is 100. The box ends at Q3, which is 108. And then the right whisker ends at the last data value that is not an outlier, which is one of these data values. One of these data values right here. in this stack of 3, which looks like it's at about maybe 116. Next, the question says to describe the distribution by addressing the 4 topics below with a brief statement. Well, if we look at this histogram here, we can see that the right side of the box is much wider than the left side of the box, and we can also see that there are 3 outliers on the right side. If we look at the histogram above, we can also see that its shape is stretched out towards the right. So this is a right skew distribution. For skewed distributions, the best measure of center is the median, and we know from above that the median is 100. We just discussed the shape of the distribution. Because it is stretched out to the right, we can say that the shape is right skewed. For skewed data, the best measure of variability is the IQR. The IQR is equal to Q3 minus Q1, which is 108 minus 98, which equals 10. And extreme values and outliers. There are 3 extreme values, which we will call outliers, and they are located at about 135, 138, and 140.